was him. That guy was trying to take pre-cal summer one and because he comes fall out. Yeah, but it's like that's what he asked.
There was two people that did it from my prior class. I mean, they'll build it. They both built pre-cal the second time because it was like. So I was like, this is fine. Maybe. I don't know.
Okay, y'all ready to get started? 1 o'clock?
Just out of curiosity,
Yes.
how much of this is taught out of the book?
Out of the book?
Yeah.
Everything?
Okay.
What do you mean?
So someone could essentially teach themselves pre-cal just reading their book,
You can teach yourself all of the mathematics.
just out of reading the book.
Yeah. In fact, as you progress through college, that's what you do. I mean, when you get to if you do grad school, you take a book and you learn, you
Okay,
teach.
awesome.
Yeah. So,
The reason I asked is
yeah.
because I had originally signed up for your class like weeks ago. I
Yeah.
forgot about payment deadline. I got dropped, and you being a coveted teacher, my spot was filled pretty quickly.
Okay.
But I mean, I thought about it, and I came to the solution of just opening my textbook and teaching myself. But I mean, this.
well, the problem with that is that you have to be good at learning out of a textbook, and that's a skill that's acquired over time. But you can do it. Yeah. Okay, so my name is Robert Digiovanni. So I am the instructor for this course. I'm a full-time instructor here, so I don't know if that means anything or matters to you, but I'm not. This isn't a part-time gig for me. Everybody's in the right place? Yes? Okay, I'm going to start out by passing around a sign-in sheet. Should have your name on here. Just initial in the box down the column that has the date. And if your name is not on here, I've left some space. You can add your name to that and initial. Okay, I'm going to start it over here. And just make sure that gets around. I'm gonna pass that out every day. Well, I'm going to forget, but please make sure that you sign that every day that we're here, because I have to keep track of your attendance. All right? Okay, let's get down to business. Gonna bring up our Canvas page. Now, I'm not going to spend an hour and a half going through this website because that'll just bore you to death, and I'm sure you came here to do some math. So I'm just going to hit the highlights, all right? First of all, there's a camera sitting in the middle of the room. That camera, I'm going to record all my lectures. So after class, well, I don't know if it'll be directly after class, but sometime later today, I will upload that video to YouTube, and then you'll be able to watch that lecture over if you'd like. It's not a substitute for being, for coming to class. Like, don't be like, oh, I'll just watch his lectures and not come to class. Because I take attendance, you get 4 absences. After that, you can be dropped. But there's kind of 2 reasons I have the camera. One is you can pay a little more attention to what I'm doing instead of trying to copy down what I'm putting on the board. And then the other thing is, if you do miss class for a legitimate reason, you get sick or something like that, you know how it is where you're not there for one day and it seems like you're completely lost, right? So at least you can go back and see what we've missed. So if you do miss class and you email me and be like, hey, what did I miss? The first thing I'm going to tell you to do is watch the lecture. And then from there, if I gave an in-class assignment or something, it'll all be there, all right? Now, this first link here is the link to the lecture videos. It'll take you to YouTube, and those videos will appear as time goes by. And then the link below that is the link to the homework solution videos. This is the first time I've taught pre-cal in 8 years. I think it's probably been 8 years. I normally do Cal 1, Cal 2, Cal 3. That's usually the sequence I do. So this semester, I wanted to get a good set of videos out there because I've got videos for all my calculus sequence. I don't have any videos for pre-cal. So this semester, my goal is to get a good set of videos out there. So what I'm doing is all the homework problems that you are going to do, I'm going to do also. And I'm going to do them on camera in an office. I did the homework assignment for tonight. I did that before class. So if I click on that right now, it'll take you to YouTube, and there it is. You can't read it, but it says Homework Solutions 2.4 Circles. So just to give you an idea, it's me working on a board. And there's audio, but that's it. So my goal is to have videos for all your homework problems up there. Now I might skip a few because they may be so similar that I don't need to show you another one, but 90% of them I plan on doing. And then any files, handouts, anything like that, I'll put here, and once you go there, you can sort through them. Class schedule, that's worth us talking about. I would recommend you print this out, download it, print it out. And this is our plan, all right? I know this is hard to read from where you're sitting. Yeah, that's practically impossible. So let me zoom in a little bit. And is there a ruler around here? Here, can you someone hand me that ruler? Thank you. This is my ruler / pointer. All right. So this is the tentative schedule. This is the plan, all right? We may deviate from this, just depends. Today we're going to do circles, and then we're going to have this as a homework set. I expect that you would do that homework before we meet again. And this is the whole semester laid out. There's a Monday holiday, but this Tuesday, Thursday class, so that doesn't matter. And then we progress through. You can see where your first exam is, then your second exam, and third exam. I'm going to try and squeeze the third exam on the Thursday before drop date. So I normally grade the exams the same day you take them. So sometime in the evening, I would grade them. You would know where you stand in the class, and you can make the decision if you want to stick around by that Friday. And then, Thanksgiving? We have Thanksgiving in here. And then we continue through. All right? Any questions on that? The final is scheduled for Thursday. Our final is on a Thursday, the 14th of December. And this class starts at 12:30. Our class starts at 1, right? The final starts at 12:30, and it ends at 3:15. So just be aware of that. Don't want anyone to be surprised by that later. All right. Okay, and then the syllabus. All right, so my office information is here, where my office is located, Juniper Hall, that's this building. Room JH1110, all right? And then I also give you my cell phone number. So I don't want you to ever feel like you're stuck without any help. So if you're ever working through a problem, can't figure it out, look at the homework solution videos, still don't understand something, then just give me a call or text me. I just ask that if you do that, make sure you put in the text your name and what class you're in. That way I know. You look familiar. No? Okay. All right. So also, I plan on getting the Note 8. Y'all know what I'm talking about? The phone. You know the Note 7, the one that caught on fire? You heard about that? Yes. You had a Note 7?
I had it.
Yeah. I'm going to get the Note 8 because I love the Note 7. Anyways, it allows me to take a picture that you send to me. Like if you take a picture of your work, I can write, find your mistakes and write back. I hopefully will have that by mid-September. So even if not, if you're having trouble with something, take a picture of your work and text it to me. Like I can't figure out where my mistake is, and I can help you out. All right? Office hours. I'm available in my office for you to come in and get help. All right? Just walk in. Hey, I need some help on something. Tuesday, Thursday, I'm a little limited on my office hours, 11 to 12:30. So before this class, for about an hour and a half, 2 hours, I'm in there. Monday, Wednesday, I have a few more office hours. Fridays are by appointment only. Okay, so it's only because we have committee meetings and things like that, and every Friday is different for me, so I can't commit to a time slot. All right? So if you want to meet with me on Friday, just email me. The book we're using, anybody buy the stuff, the material? Do you have it with you? Can I see it? I have not seen it. Is this like a la carte edition? What the heck is that?
It means all in one.
Okay, it's loose leaf bound, right? And yours is not, but yours is loose leaf. Okay, you can do the loose leaf bound one. How much was the loose leaf one? Yeah, because you had it for 1414? Yeah, so this is the book everything is based upon. You have a hardcover version, and then you have the paperback or the loose leaf, and that's cheaper. Whatever. Just make sure you have this edition, which is the 10th edition. And we're using, who's the author? Sullivan. Sullivan's very, very well known for college algebra, pre-cal, and even calculus.
You can rent that book on Amazon for
$30 rental, okay. So however you find it, get it as soon as possible, because you'll have homework out of it tonight. I believe that the library has those on hold, so if you, or you can come take a picture of the homework assignment out of the back of my book or off someone else's before you leave. All right, I'm not going to go through the objectives and the outcomes, but let me just tell you this. You know, what is pre-cal about? Like, what is the whole point? What we're trying to do here, there are elements of pre-cal that you're going to need in calculus, all right? But it's not necessarily like everything we do here is required for calculus. This is more about, I always tell my students, pre-cal is about maturing. Maturing as a mathematical student is raising the bar to a higher level. That way when you get to calculus, you're prepared for the rigor that's involved there. So it's just about growing up a little bit in terms of math, doing your homework, becoming neat, you know, building your confidence, right? Those sorts of things. And then, of course, there's interesting stuff here, trigonometry and... All right, so our evaluation, we have a standard grading scale. Now, your grade, I'm not going to go into all the details of all this stuff. I'm just going to tell you what the grades are or how it's broken up. You have classwork, homework, classwork, and a portfolio. So I'm going to have you keep a binder together of all your work, and I'll collect it. I'm not sure if I want to do it at every exam. Let's just, right now, let's say every exam. You're going to bring all your book or all your stuff, all your homework, everything in that one binder, bring it to the exam, and I'll give you some sort of grade for it. And that's 10% of your overall grade. So if you show up on that first exam, you don't have a binder, that's going to cost you, well, there's 4 tests, right? And it's 10%, so 2.5% right off the bat. So you want to make sure you bring it. And what's supposed to be in there and the order and all that is in detail later on in the syllabus, but I don't want to go into it. We'll also have quizzes. So quizzes can come in the form of anything. I can just be like, all right, you walk in, I'm like, all right, we're going to do a quiz today, and everyone's all upset, and then I give you a quiz. Or I could say, all right, we're having a quiz, but it's a group quiz. Y'all can work together. Or I can say, all right, you can use your homework on this quiz. Or it might be an attendance quiz. Like I look around, there's too many people missing. Okay, sign this sheet. It's a quiz grade. You know, so those can come in any form at any point in time. And then exams. We already talked about the 3 exams within the semester, 60% of the grade. Final exam is equally weighted, and my plan is for the final to not be comprehensive, but it's going to depend on you as a class. If these exam grades are low in terms of the class performance, then the final will need to be cumulative. It will need to include concepts from the previous tests because I need to make sure you understand them before you move on. If you all do real well on the first few exams, I see no need to give you one more comprehensive one. I just give you an exam that's shorter and just covers the material towards the end. All right? No exams are dropped. No replacing lowest grades with anything. It's just you got to be ready on that day of that exam to come in and perform well. I know I hear a lot about test anxiety, and I understand it's a real thing. But like I said, being in pre-cal, part of it is about maturing and becoming a better student. Test taking is one of those things you have to be better at. It's not my rules. I mean, it's just that's the way college is. I can remember many courses I took as a junior, senior level courses in college where I had 2 grades, midterm final, 50-50. That's it. That's pressure. You walk into a classroom, you got an hour, 40 minutes for half your grade. Right? Doesn't sound fair, but that's life. That's the way it was. So you need to get ready for that. And we'll talk more about it when we get closer to the exams, like how can you prepare? How can you get better at being ready? I think that's the biggest thing students miss is actually putting themselves in a testing environment at home and trying to do problems without any resources and seeing, practicing that. Questions, comments, concerns? Okay, this goes into more detail about the portfolio and everything else. All right, course policies, what to expect. I already said I'm going to be using technology. I'm going to record my lectures. If I have any lecture notes, right now I don't have any to hand you, but I may provide some online and I'll just put them under class files. We'll just see how things go. Electronic device policy. My classes never liked this policy. All right, so you may use a laptop or tablet to view lecture notes, which I don't have lecture notes for you right now, in class, but using any electronic device to do anything unrelated to this course will result in a 10% penalty on your next exam. You also have to leave the class, and you'll be counted absent for the day. So, as an example, okay, okay, you see the point? The point is, Brody?
Huh?
Brody? What was your name?
No, Zach.
Oh, what did you?
I said Brody.
Oh, sorry. Zach. So Zach just missed a very important thing, right? Zach, that in the future on your phone will cost you 10 points, 10% on your next exam. Okay? You clear?
Yes.
Okay. So if you need to be on your phone, if there's anything that's important, I understand. I'm not putting this above your life, but just take it outside the room. Just go sit on the bench out there, do what you got to do, come back in. All right? That sound fair to you? It's the rule, so I guess it's got to be fair. Behavior is the same thing. I usually don't have a problem with disruptive behavior, but sleeping is something I don't tolerate. So again, if you're tired, if you feel yourself like nodding off, just get up, walk out, go do a couple of reps of going up and down the stairs, do some push-ups, whatever you got to do, get your blood flowing, come back, all right? Because if you're sleeping in class, I'll take 10 points off your next test and I'll tell you to leave. All right? Okay. Anyone who doesn't like policies, you have the freedom to not be in this class if anyone, no? Can y'all handle it? Is it all right? Okay. All right, tutoring, 6-drop rule, SOBI statement, all that stuff is stuff I need to have in the syllabus. Just be aware that there's tutoring lab right here. There's one here and there's one on the other side where you can go get help. And the hours are posted. They're there pretty much like 7 or 8 a.m. all the way into the evening. And I recommend that you form study groups, make some friends, go do your homework, right? I mean, I know that that's one of the lessons I learned as a student is that you can do it on your own for quite some time. But I think there comes a point in time where you can help each other and you can learn a lot from others. And so I can remember going into the library meeting with friends, and what we would do is we would divide up the homework, and I would do some and they would do, we'd each do our part, and then we'd come teach it to each other. I mean, now that was more like, higher level stuff, so it was, it worked out better, but still, in the group, right, in that group, you can learn a lot, especially if you're helping someone else understand something. All right, SOBI statement. This just has to do with the fact that we have to pay attention to how people are behaving and what they're doing and what they're saying. So if you see any suspicious sort of weird behavior, just report it. Say something to someone, right? For a long time, since I've started teaching, every single day, first day, I've always talked about a plan if we hear gunshots or, what's our plan, right? Which maybe 10 years ago sounded crazy, but nowadays not so crazy, right? So what is our plan? We start hearing gunshots.
Well, I mean, it depends on how you feel. I mean, if you wanted to stay in this room, you could easily use these desks, barricade that window, and then the likeliness of bullets coming to this, is possible. But I mean, that's why you have more tables.
All right, so tables are an option to barricade. I agree. Let's just see. We're on the 3rd floor, but you never know.
Can you actually open the window?
Oh yeah, can we open the window? If bullets are flying, I'm pretty sure we can open the window. There's an awning right here. It's a 6-foot drop to an awning, and that awning wraps around the building. So there is a somewhat of an exit here. All right.
Turn the lights off and make the classroom dark and vacant, lock the door.
I'll tell you what I don't want. I don't want to be curled up in the fetal position under a desk waiting for my destiny. All right. So I mean, you can do that if you want. I'm gonna probably see if I can get out that way, and if not, I'm gonna go out that way.
It'll all take some cognitive decision making.
Exactly.
At the time that it happens, and you'll have to be
That's right.
situationally aware.
That's right. And you never know how you're going to react till you're in it, right?
It's the better thing.
I just don't like the idea of not. I guess I was just raised this way. Every time I went to a restaurant with my dad, he would always ask me, "Where are the exits? Where are the exits?" And I thought my dad was paranoid, but now I realize he was just trying to be prepared.
Never sit with your back to the door.
Don't sit with your back to the door, things like that.
I mean, really, though,
Okay.
you could just lock the door, put a table in front of the window, and you go back to teaching.
We could. There was and when I was in grad school, I took a one of the toughest courses I ever took was called functional analysis. And we were in there, we were going through this lecture, and the fire alarm started going off at the university. And we all started like packing up our bags, and our professor was like, stay here. And we just kept on going with the fire alarm going off. All right. But no, if I hear gunshots, I think we can cancel class.
Within form of human chain down that window.
6-foot drop, you don't know till they sound a gunfire.
All right. Everyone know that it's now legal to carry on campus if you're licensed? Okay. All right. So that gives me some sort of peace of mind that at least there would be some people that would have. Okay. I don't know. Okay. Let's get out of this syllabus. We're done. All right. I am going to ask you to do an assignment that is due Thursday, I believe, by the end of the day, 11:59 p.m. All this is you click on it. It's a yes or no question. I understand the requirements of the course, or I do not understand the requirements of the course. And that's just you just signing off on the syllabus. That's all that is. So that way, later on, when you walk into exam 1, you're like, hey, the portfolio, I don't know what you're talking about. And I'll be like, but you said you did. So, yes. Sir? Yeah? What's on your laptop? Okay, I just want to make sure. All right. Very good. That's fine with me. All right. Any questions? No? Okay. I feel like I'm forgetting something. All right, let's talk math. We're starting with circles. Normally, in the pre-cal class, you start off in a section, chapter 12, which is at the very end of the book. And the chapter is, the section we start off is called partial fraction decomposition. And that section is pretty rough in terms of the algebra that's in there. But I don't like to start with that section. Okay, and then also most pre-cal classes that are taught here, they go with the partial fraction decomposition, which is very heavy with the algebra. I think the point of that is just like make sure your students know how to do algebra. I get that. And then they go into a review of exponential functions and logarithmic functions. And to me, it's like, okay, well, you've done that also, so that's still review. What I like to do in pre-cal is I like to start off with the trigonometry right away. because if we're reviewing stuff, I feel like we just kind of, not waste time, but I want to pique your interest right away. Like, let's start talking about the trigonometry. At the end of the course, we'll go back and take a look at anything we need to review in terms of partial fractions or exponential or logarithmic functions. But let's start with some trig and some geometry. And what better place to start than the circle? All right? So 2.4 is circles. Now, when we talk about a circle, I mean, we obviously all know what a circle is, right? But can somebody tell me like a formal definition of it? Can you think, if you're trying to explain what a circle is to somebody?
Are you referring to the pi circle where it's broken into fractions?
Nope, I'm just talking about a circle. Just a circle in general.
Continuous loop.
Continuous loop, okay.
An infinite amount of
Is that enough? If I say continuous loop,
A continuous curve.
okay, that's a continuous loop, right?
I would say
So
circle
let's
is
add some more detail to that then.
It's like an infinite of edges.
Infinite number of edges.
Yeah. Because the more edges you start out, the more of a circle it becomes.
I don't know. I'm trying to challenge your definitions
It's
here.
like you have a square, and then you add another edge that's a pentagon, and then you go from there. And then the more edges you add, then
Okay.
it eventually just becomes like, to the mind, to the naked eye, it looks like a circle.
I agree, but we could argue that same thing with this. There's something else in a circle that is important here.
Continuous shape formed at a 360 degree.
Continuous
Shape formed at a 360 degree.
360 degree, continuously shaped form.
A round plane figure whose boundary consists
There you go. There you go.
equidistant from the fixed point.
Okay, now that's too technical, I think. But it is. That is the definition. But think about it. Look, if I'm trying to describe a circle, let's start with the point that we know is probably the most important, and that's all circles would have a center, right? And then how could you describe, well, I say all circles have a center. They have a center, but that point, the center is not actually part of the circle, right? Every point on the circle has what property connected to that center?
All the outer ring is consistently the same length.
Okay, that's the key. If you were to say, here's a point, right? And then give me a fixed length, which we call the radius, right? So let me fix a length here. I'll just say that's some fixed length. Now, if I take a measurement from that point, the center, to some other point and mark that, and then I do that, and I get all the points that are the same distance from that center point, then I will have to draw a circle, won't I? You could also imagine this being like a string, and I just wrap around, right? So the definition of a circle is the collection of all points that are equidistant from some center point. Yes? Now the book has a formal definition in here. I don't know what you're reading, something off Google or... I'll read it out of the book. A circle is the set of points in the XY plane. Now this is important also, because when we talk about circles, we need to make sure we're talking about a flat sheet of paper. All right? Flat sheet of paper. If we're in the XY plane, it's all the points that are a fixed distance r from the fixed point hk. So what we like to do is we like to represent this point in the middle as the center as an ordered pair hk. That's the standard letters we use, h and k. And then we have a fixed radius where all the points lie this distance, and that's r. Okay, so hk is the center. And r is the radius. Now, before we proceed on this, I'm going to give you a little short mental quiz here. Can anybody give me the general equation for a line?
Y is equals mx plus c.
Okay, lines, y is equal to mx plus b, right? That's we called that the slope-intercept form of a line. That's the slope-intercept form of a line. Can anybody remember the general equation for a parabola? Or, yeah, a quadratic parabola.
Y equals x squared. Yeah.
Okay, y equals x squared would give you that what we call one of our toolbox ones, is like the most generic, basic one. What about an arbitrary parabola? It's got x squared in it, but it's got more stuff. Ax squared plus bx plus c, right? That's one form of a parabola. There's another form where you can write it this way. See if this looks familiar. Ax minus h squared plus k. Does that look familiar? This is the vertex form. This is what we call the standard form. And what these equations did in algebra is they gave us, for certain geometric shapes like lines and parabolas, they gave us a relationship between our variable x and our variable y, right? So if you construct something that looks like this, I'll give you a specific example. Y equals negative 3x plus 5. If I have an equation that looks like this, I know it's a line, right? I know it's a line. And if I have something that looks like this, I know that if I graph that, it's going to look like a parabola. So this one, when I say it's a line, we know that it could be like slope is positive, slope is negative, right? Slope is 0. What about vertical lines? Slope is undefined. So, but that's the relationship between the x and the y variable. Here, we know that that looks like a parabola, which looks kind of like a U. In this case, it would open up, right? Because it's positive coefficient in front of x squared. If it was negative, it would open down, right? So I think one of the natural questions would be, if you draw a circle, which again is a geometric shape, is there some general formula or general look that a circle has in an equation that would give you that relationship, that would draw that picture? And the answer is yes, there is. It's the standard form of a circle. All right, so that's what I'm about to give you now.
X minus h squared plus y minus h squared.
That's the one.
Equals R2.
X minus h squared plus y minus k squared equals r squared. This is what we call the standard form. Okay, that's the standard form of a circle, and you need to just hardwire that into your brain. So in order to actually have a specific example, like here I gave you a specific example of a line, a specific example of a parabola. To give you a specific example of a circle, I would actually need to replace h and k with numbers, right? And replace the radius with a number. And if I did that, I should be able to have a specific example, all right? So let's try and come up with a couple of examples. Find the equation of the circle with radius 3 centered at -2, 5. So what am I asking for here? What are we trying to come up with? You always want to know what you're trying to do, right? Before you do anything. What do I need?
The standard form of
Yeah, I'm asking, we want to know, we want this, right? We want this right here, but we want to be able to replace the letters using that information. I'm given in this problem, okay, so I'm ready for the solution here. I'm given two pieces of information here, right? I'm given the radius is 3, and I'm given the center, which is HK, which is -2, 5. I'm like off camera, I think, here. It's pretty close. I'll move this. -2, 5. All right. So this is part of what, when I was talking about like kind of maturing as a mathematical student, you always want to think about when you're asked a question, what is given to you, what you're trying to go after. It helps sort things out in your mind. All right, so let's use the formula. All we're going to do is rewrite this, right? Just plug and chug. So I'm going to rewrite this. I'm going to say x, parentheses, sorry, x, and then I'm going to put minus h, which for us would be what? Be minus -2. So it'd be +2. You have to be a little careful with that formula. This is +2, that quantity squared, plus y, now what? -5, because there's a minus in the formula. So if this is positive, it's just going to be -5. That quantity squared, and then equals r squared. R was 3, so 9. That's it. That's the standard equation of a circle, of that circle.
And now, do you solve that, or you just leave it as is?
There's nothing to solve for, right? I mean, because it's an equation. This is a good question, all right? If I ask you to solve this equation, if I ask you to solve this equation, could you find a unique solution?
Yes.
Yes. Now, if I change this to x squared, could you find a solution? Probably, right? Unless you get imaginary numbers in there. But if I add another variable in here, like this, you now have an infinite number of solutions because you have one equation and two unknown variables. You cannot find a unique solution. In fact, this is a line, isn't it? So there's an infinite number of ordered pairs that would solve this. There's some x that goes with some other y, and then there's a different x that goes with a different y. So there's no solving to be done here. You could isolate y, right? You could solve for y, but you're not actually getting a solution.
You'll have a variable inside your solution.
That's right. Here, same thing. Now, I could ask myself, what x's and y's could I plug in here, right, to make this true? Like, are there some x's and some y's that would actually make that true? Yeah. How many of them are there? How many pairs of x's and y's are there that could make this true? A lot? Well, remember, what does this mean? This is a circle centered at -2, 5, right? That's the center of my circle, and it has a radius of 3. And what that means is that if I pick a point off of here, if I pick the correct x and y, right? If I can find numbers that make this true, then that point lives on this circle. All of the ordered pairs that make that true create the entire circle. So there are an infinite number of solutions. I don't know if that, does that make sense? Okay. But you can't write all the solutions, right? You don't have enough time in your life to write every single solution. So instead we write the equation because the equation represents all the solutions. Is that pretty straightforward? Someone gives you the center of a circle and a radius, you're in business. Yeah? Okay, let's change the problem just a little bit. Let's change the center to 0, 0. I started out with something a little more complicated, -2, 5, because I wanted to move the center of the circle off and up a little bit. But there, the center of the circle is actually right here at this point, which we call the origin. Thank you. Right? So this circle is just at the origin. And it has a radius of 3, so, something like that. So what is its equation? So how is it going to be different than this one? So I'm doing a different example right now. Yeah, I'm going to write it this way even though I shouldn't. I'm going to write it like this.
X squared plus y squared.
Wouldn't that be the equation if I plugged in h and k? But what is x minus 0? Just x. So this is just x squared. And then this is just y squared equals 9. So when you see an equation that contains something like this, x squared plus y squared, and it's not like this, right? No numbers next to them in the parenthesis, that automatically, you should be thinking that's a circle centered at the origin. You need to see that there are zeros next to those, to the x and the y respectively. All right, I'm going to change it up just a little bit. I want to find the equation of a circle centered at 1, 1, which is tangent to the x-axis. So this is a different example, right? Let's draw a picture. I have a circle. The center of it is at 1, 1. That's my center. I'm trying to find the equation of the circle, so I need h and k, and I need the radius, don't I? I have h and k, 1, 1. But do I have the radius directly given to me?
No.
It's not directly given to me, is it? But it's in there, right? The radius is in there. So instead of writing down what I'm given here, I'm just going to write down something here that I want. I want to find r, right? Because if I have r, I'm in business. That's the only thing I really need that's missing. So if I draw my circle here, what does it mean for me to say that the circle is tangent to the x-axis? Just touching it, right? So like if I drew a circle like this, that would not be tangent because I'm actually crossing the x-axis at 2 places, right? I just want to touch in one spot. So I want my circle to go like this and just touch the x-axis. With me? So the radius in this case is 1 because it is equal to the vertical distance from there to there, isn't it? That vertical distance is your radius. So r here should be 1. Follow? So r is 1. And that means the equation should look like this. Well, you can tell me. I'm just gonna put it here and you can help me fill in the blanks. So it'll be x what? Minus 1 squared plus y minus 1 squared equals 1. That's your standard form, standard equation for that circle. Questions on that? What if I had said y-axis? It would be exactly the same, wouldn't it? Because the distance from here to here would have also been 1. I kind of gave you a boring example here. No questions? Sure. I have one that's a little harder. How about if I ask, pardon?
How did the circle appear on the other side of the x-axis or the y-axis?
How did I?
How would you? Like, say, how would you say?
You mean like if I want that over here? Okay, so think about it. What would need to change? Would your y need to change? Would your up and down? Okay.
Positive, negative, so you give it a -1.
And then it would become +1 here. Yep, exactly. So if you wanted that circle right over here instead, you could just make that a +1.
And the same thing for y if you wanted it to reflect the opposite.
That's right, if you want to move it down. Okay, find the equation of a circle centered at, I'm going to change this because 1, 1 was too boring. Let's go with 3, 4. It's still kind of boring, but let's go with 3, 4. But this time, I want to find the equation of the circle at that, centered at that point, which is tangent to, the origin. Ooh, that's a little more. The book doesn't even ask you to do that, so this will be a little more thinking involved here. Any ideas? Should we draw it first, maybe? Might help us to draw it. I'm going to go out 3, up 4, and draw center. And then I want my circle to just touch the origin, which is this point right here, right? So when I draw that, go off there. I don't know, something that's terrible, but you get the idea? Do you all agree? Anyone have any idea of how we can find this radius? Because that's all we need, right? We're given the center again. We want to find R. That's right. You could use a distance between 2 points. I totally agree with that. But because the other point is the origin, I think you can make it a little bit easier. Look, we want this distance, right? That's right.
That's right.
Why don't we do this?
Pythagorean theorem on this.
Yep. Y'all see that? We want this, which if we draw a right triangle, really just turns out to be the hypotenuse of this right triangle. And then this distance right here is 3. This distance right here is 4. And so if we want to know what R is,
Square root of 18.
we can just do a squared plus b squared equals c squared, right? So we know that 3 squared plus 4 squared equals r squared. So 9 plus 16 equals r squared. So 25 is r squared. And that means r is 5. There's a negative solution to that equation, but r is positive in our picture. So yeah? So the radius is 5. So now we can write it down. Let's write the
Couldn't you
equation.
have just figured that out by, you see where your radius is, and then you see the distance from your radius to the origin is 4, but you see the circle goes 1 past, so couldn't you just add another
Circle
number?
goes 1 past.
You can't assume that because the different things, like you'll get really weird numbers if you.
I gave you a problem. I gave you intentionally what we call a Pythagorean, part of what's called a Pythagorean triple. I gave you 3, 4, and if the sides of a right triangle 3, 4, 5, that's called a Pythagorean triple. But I could have given you 3 and 7 here, and then that whole idea is going to kind of fall apart.
You can
Yeah.
still solve it.
You could, you're going to get an irrational number probably.
Most of the time.
Okay, we good? I'm going to write the equation. It's x minus 3 squared plus y minus 4 squared equals 25. That would be our equation. All right, now on the previous problems, I stopped here and I didn't ask you any more questions, right? Stopped here? But now I have some additional questions I'd like to ask. Something we did in college algebra quite a bit. What are the x-intercepts of this graph? Where does it hit the x-axis?
3 and 0.
We know here, right? It hits, but it hits somewhere else over here, doesn't it? And then the y-intercepts are here and here. So I'd like us to go try and find those things. So let's find the x and y intercepts. All right, let's start with the x-intercepts. Can anyone remind us all how you find x-intercepts?
Set y to 0.
Set y to 0. Set y equal to 0. Solve for x. Right? That's what we're going to do. That's how you find x-intercepts. Replace y with 0. And remember geometrically why we do that. If you're trying to figure out where this thing hits the x-axis, then your y coordinate must be 0, right, to be on the x-axis. So that's why y gets replaced with 0. So let's go to the equation we just found, right? And let's find the x-intercepts. So I'm going to go up here, I'm going to replace y with 0. So I've got x minus 3, that quantity squared, plus what? 0 minus 4, so negative 4 squared equals 25. And now what you have is an equation, but now you only have one variable. So now we can actually get a solution to this. In fact, there are going to be two solutions because it's a quadratic. So let me clean it up. We're going to square the negative 4 and get 16, right? Then we're going to subtract on both sides, right? I'm going to erase this. We're going to subtract 16 and we get 9. So we have x minus 3 squared equals 9, right? Yeah, for this, the easiest way to get to it is just take square root right now. You could expand out the left side, but then you'd have to use either factoring or a quadratic formula. Here, it's easier just to square root. So if I take the square root of the left side, I get x minus 3. If I take the square root of the right side, I get, good, plus or minus 3. Do not forget the plus or minus, because then you lose half your solutions. Planes fall out of the sky. Things like that. Got it? And now add 3 to both sides. And so we're going to have two answers here. One answer is 6, and the other answer is 0. And so if we write this as ordered pairs, remember these are x-intercepts, so we're going to have 6, 0, because the y-coordinate was 0. And then the other x-intercept was 0, 0, right? So 6 and 0, and then the y's were 0. So those are where we would hit. And from my drawing, this one we could agree with. This one was, you know, yeah, you can kind of see through the, there's some symmetry going on here, but how about the y-intercepts? How do you find y-intercepts? Set x to 0, right? And go through the same thing. I'm not going to do that. I'm going to let you do that yourself, all right? You get the idea. On your homework, you have to do that. You have to find the intercepts for circles. So get your x-intercepts, set y to 0, solve for x. To get your y-intercepts, set x to 0, solve for y. It's the reverse. All right, good, good, good. How are we doing on time here? Oh, plenty of time. Great. More circle stuff here. How about I let you work on one, and y'all can, you know, you can talk to your friends there. Find equation of circle centered at 1/2, -3/4 with radius r equals 1/3. All right, so this is just to get you to mess with fractions a little bit. So go ahead, take a minute or two and just write out that equation. You got it? Okay. Should have x minus a half squared plus y plus 3/4 squared equals 1/9. Now I gave you this because I wanted to ask you if this would be the same thing. Would this draw the same object, the same circle? Would that draw the same circle?
Yes.
Yes, it should, because all I did was what? Multiply both sides of the equation by 9, right? This is standard form. This is not. All right? So even though they draw the same things, this is not in standard form. Because you have numbers in front of these parentheses, you do not want that for standard form. You want basically like a 1 out here and a 1 out here. Just FYI. Okay, we're just going to change it up just a little bit. Standard form. Okay, that's our standard form. Nothing new there. There's another form. This is just like parabolas. Parabolas had a standard form and a general form. Or there was a general form and a vertex form. For circles, we have standard form, and we have also what's called the general form. I know it's confusing. All right, and this is for circles. All right, just make sure we're still talking about the same thing here. For circles, standard form, general form. Here's what general form looks like. Let me make sure I use the same. Yeah, okay. They put the C on the other side? Oh, no, they put C there. Okay. Now, I know that may look weird, but let's do an example and you'll see how this happens, how you can get from standard to general. So let's take this circle right here. What's the center of that circle? 4, -1. Radius? 5. Okay. Now, I want that. That's in standard form, right? Let's put it into general form. What's the big difference between these two forms? There's no parentheses, right? There's no parentheses, which means that I have an x squared term, but I also have an x term. Here I have a y squared, but I also have a y term, and then a constant. Here, if I wanted to get from here to here, what do you think I would need to do? Just to eliminate these parentheses, right? So how about we just expand that out? Do x minus 4 times x minus 4. Yeah, they're related to these, but they're not. There's not a direct. Yeah, let's expand it and we'll see. Yeah, we're going to do this times itself. That's what it meant to square it, right? And then here, y plus 1 times y plus 1, and then equals 25. That's what that means, right? And now when we expand this, I'm trusting everyone here can expand this. This would be x squared minus 8x plus 16. The next one, y squared plus 2y plus 1, and then equals 25. Combine your like terms, which in this case are just your constants, right? Okay, so I'm going to write it like this. X squared plus y squared minus 8x plus 2y, and then that's 17, right? Equals 25. Now what we need to do is subtract 25 on both sides so that we get a 0 on the right-hand side. Yep, so subtract 25 on both sides, you get minus 8. Understand? So I'm going to write it down one more time. X squared plus y squared minus 8x